Super excited to have the team from ACE joining us today. You have all of these amazing authors with us, and we're really excited to be diving into the ACE paper and talking about it in a lot more detail. Why don't we quickly go around the horn and just introduce everyone really quick? I'll start with Changrang since he's on my right.
Hey everyone, this is Changran. I'm from SambaNova Systems. I'm working with the Agentic ML side, and I guess Urmish can go next.
Okay. Yeah, everyone, my name is Urmish and I head the various ML initiatives at SambaNova Systems. I see Shubhangi on my right, so I'll call her out.
Yeah, hi, I'm Shubhangi. I work in the ML team at SambaNova. Happy to be here.
Yeah, and then I'm Jay, also work for the ML team in SambaNova Systems as well. And yeah, Kijun.
Yeah, I'm Chijin. I'm a PhD student at Stanford, and I currently work on machine learning systems with a focus on agentic systems and their capability and efficiency.
Hi, I'm Feng Lu. I'm with SambaNova Systems. I'm working on the ML team.
Hi, I'm Vamsi. I'm from SambaNova. I work on multimodal systems and agentic systems here.
Awesome. So as we have a really great group of folks, super technical, way more technical than I am, to talk into about the ACE paper. And I think what's specifically super exciting is that the team has also just released the open source code that powers ACE. So anyone can start leveraging that to start building ACE applications, which is really incredibly exciting. But before we dive into that in a little bit, I wanted to take one step back and really talk at a very high level about what ACE is. So ACE is an extremely intuitive concept which stands for Agentic Context Engineering. But for many, this might be the first time that they're hearing about it or really understanding it. So first question that I have is, can we start with kind of a background on ACE and how do we got to where we are?
Sure, maybe I can get started and talk a bit about why SambaNova was looking into it, and then Shizan can talk a bit more about academy and where things are with context engineering. So from a SambaNova point of view, we power a lot of agentic applications for a lot of real-world enterprise use cases. And one of the things that we started noticing for these agentic applications is as people move closer to adoption and productization, they want to improve the accuracy of their agentic systems. Now, the only hammer that they have right now is either sort of focus on prompt optimization on their own, which can be a bit more cumbersome, or focus on fine tuning. Now, fine tuning is a very sort of is a service that is readily available, but fine tuning it can be very challenging. You need really good, clean data sets for fine tuning, and you need to be very sure about where you're deploying your application. Now, one problem with a lot of these agentic applications is that uh, as sort of applications get adopted more and more, the input distribution that they were initially targeted for can keep expanding and keep changing. And that means the initial fine-tuned model becomes irrelevant quickly, and either you have to fine-tune model again, or you find another way to handle this problem. And that's where kind of we started looking into context engineering, finding a way to sort of look at this problem without actually fine-tuning the model.
Jian, do you
Yes.
want to quickly also talk a little bit about why this is incredibly important from a university and academic perspective as well?
Yeah, sure. So I've been before I look specifically into the ACE idea, I've been looking at system side optimization for long context workloads, with a particular focus on making these long context inference much faster by redesigning the system stack. For example, with a focus on KV cache. And later I realized that this has much more potential simply than just by accelerating the system, but also by improving the capability of the system even on itself. So I've been looking at these approaches by using the context as the way of adaptation to tune the system as an alternative or as something we use together with traditional fine tuning. And then I realized that this is something we can do in a much more rigorous way because I've been looking at existing approaches. One example approach I've been looking at for a long time is retrieval augmented generation. But I realized that RAG picks up knowledge for you, but it doesn't digest its knowledge in the way that the model needs. So that's something that is really getting important and critical especially when we have more agent applications, when you have a lot of detailed knowledge not written down in existing documentations. So that's when I started to look into ACE in the school. I think it's really important to a lot of the topics I just mentioned.
Yeah, no, I think that's great. I mean, I think that the core to it that Ramesh and you both just talked about is this fact that fine-tuning takes a lot of work, and there are oftentimes there are ways with context to really improve systems, whether that's with RAG or ACE or anything in between and more, right? And so a lot of people have been asking, and I think this is one of the main reasons that it went incredibly viral on social was, does this basically, does ACE basically mean that you don't need to fine tune anymore? Can you really just start to leverage these language models in such a way that with a really smart way of using the context to get the accuracy improvements that you need and continuously improve the performance of your agents?
So I did see a lot of discussion online regarding whether ACE actually kills fine-tuning. I would say personally, I don't think it kills fine-tuning, but it is a very it's a new paradigm or a new way of thinking that we can use either outside of fine-tuning or together with fine-tuning. So you can think of it like this. So fine-tuning is like learning about a specific subject before you take the exam. While ACE is, the way that you try to learn from exam questions and try to get better at them while you're taking them. So it doesn't replace fine tuning or it doesn't kill fine tuning. And actually, I think there are quite a few specific scenarios where ACE would be specifically helpful if you compare it with fine tuning. So one example is that, just like we discussed, in many of the scenarios, the cost of fine tuning is very high. So sometimes you touch the weights of the entire model. Even with more efficient approaches like LoRa, you just touch much smaller parameter counts. It's still a lot of cost. And sometimes if you're using these frontier models from top AI labs like OpenAI or Anthropic, you don't get to touch the weights. So you have to use their services for fine-tuning the model. But in many of the cases, you want to take control of what you're tuning or what exactly you're changing. And in many cases, training data are pretty scarce in domain-specific applications, or in some agent applications, you don't get a lot of the training data, and you don't have the training environment ready. So fine-tuning is not completely ready for these scenarios. And finally, regarding societal impact, there are some cases where we have these privacy laws like GDPR in Europe, where we have to reserve the right to undo something we learned in the past. In this case, if we have this interpretable context as the learning, the way of learning, then we can selectively forget what we have learned in the past. So all these are reasons why we believe that ACE is pretty valuable, even though traditional fine tuning is already so popular in industry and academia.
Yeah, and maybe if I can give a quick add-on on what Tijan has been talking about is, from like within SambaNova, we actually cares about the enterprise applications a lot, right? And with a lot of the times where we see is there is actually a very good need for domain adaptation or enterprise specific adaptation. Whereas interpretability is also something we care very much. And with fine-tune, it's kind of like, there are also a bunch of literature shows that if you fine-tuning the model not carefully, you potentially can having some increasing some of the possibilities for hallucination. And the kind of like, you have to treat fine-tune as more or less a black box when you're using that for downstream applications, right? But then for ACE, actually what we're doing is to keeping a playbook that has been sort of like evolving while the agent is being exploring new experiences. So with that, you actually can, any of these domain experts from the enterprise, they can actually see and check what's going on in the playbook. And if there's anything, let's say, go against the laws or the policies of the company, they can easily just removing those pieces so that will be something they can have full control over. So it's a white box that they can just check and maintain in a very intuitive way. They don't need to know too much of the in-depth knowledge of ML.
Yeah, no, that's a really great point, and I think being able to allow, especially in an enterprise context, it's not just developers, but potentially business analysts that might want to engage in improving the capability of an agent is incredibly valuable.
So maybe just to add to
Yeah.
that, I think so. I mean, the goal was the project was never to kill fine tuning or even replace it, right? The goal of the project was always to provide an alternative to fine tuning, right? And beyond everything that Shizeng and sort of Changran talked about before, the reality is when it comes to agentic applications, the landscape is always evolving. And the applications, as they see more adoption, you do see a distribution shift, either because you attract users from new geographic locations, or people are using the same application in a different way as they get more familiar with the tool, or they build more trust in the tool and sort of trust it with more sort of use cases. And that means you are always, if you don't have any alternative to fine tuning, you're always fine tuning, right? And that adds into all of the things that was talked about previously. So there was always, it sort of seemed like a right time to sort of look into if there are other ways beyond fine tuning to actually improve agents. And I think that's where the ACE fit in.
Yeah, especially these long sequence capabilities gets much more matured, right? Like the 120K, 128K kind of sequence lenses, which you can't imagine like 2-3 years ago. Yeah.
Right. Which exactly leads into like until ACE, like how did people do this before? I mean, fine tuning was an option, RAG was another option. What else did people really have at their disposal before you brought ACE along?
Yeah, I think I can start off by talking about it. So, online test time adaptation is another sort of paradigm of techniques that were used to handle these kind of problems. And among them, I think dynamic cheat sheet is a very prominent approach that came out, and that also serves as one of the inspirations for our ACE framework. However, one limitation of dynamic cheat sheet is context collapse. So while I was trying this approach with some of the domain-specific finance data sets, what would happen is the context, that is the length of the playbook that we would be curating during the training phase, would suddenly collapse. And this sudden, abrupt shrinkage of context is what proved to be a very it was a delimiting factor for us in like trying to scale this to bigger training data sets. So this is something that the ACE framework tries to correct by the grow and refine component of the ACE, where we are accumulating knowledge while we are also making sure that the context increases steadily, and we are trying to control the redundancy that is captured in this increasing context. Um, so that's how we are able to like tackle the context collapse limitation, which was previously seen by some of the test time adaptation strategies.
Yeah, another line of work which has been very popular recently is to tune the specific prompt you have using, for example, optimization strategies or using different kinds of evolution algorithms. So one example is in the space is we've been looking at approaches like JAPA, which have been improving the prompt using the evolution algorithm and taking a look at the validation accuracy of these generated prompts. These approaches have been very powerful, but we do observe that one specific limitation of these approaches that happens is what we call the brevity bias. So if you generate a specific prompt using these approaches on a specific task, in many of the cases, for example, for some of the prompt optimization approaches, they would use, for example, a budget algorithm, or they would use a separate validation set for picking the best prompt. And our observation, especially on the agent tasks, which Jay will introduce very soon, is that because we have a very tight budget, and in many cases, the optimization process is designed in a way that try to generate something that humans can understand or favor. So sometimes we would be dropping a lot of the domain-specific insights or details, domain-specific details from the optimization process. For example, if they are not immediately helpful to raising the accuracy during the generation phase. So these approaches are very timely and good approaches, which we would talk about very soon later, is that they can also be used together with our framework. But this brevity bias is something we observe that happens with a lot of the approaches. And Jay can give some very specific examples on this.
Yeah, so I guess when we kind of started to adapt these system prompt evolutions into one specific task, specifically app world, Some things that we did notice was after like each iteration, looking at the system prompt that was being, I guess, adapted there. One of the main observation is that they do like the system prompts that are being appended or being updated. They do provide, like, I guess, good information in terms of like how to be able to tackle some of the APIs at hand. But over time, you can kind of see that sometimes the specific APIs that are being used or specified kind of change, and it doesn't really capture the full entirety of like all the types of API calls that you might necessarily need to use during the test set. So it might be able to perform well on, say, the validation set, where maybe it's a little bit smaller in terms of that. But for the overall, I guess, test set at hand, it might not be able to capture all of the diverse API calls that you might necessarily need. And I think on top of that, like one other observation that we did notice is that sometimes the system prompt, how it evolves, is not necessarily adding in more information, but really just changing how it phrases the information sometimes. So like sometimes it goes from like a markdown file to maybe more so saying like, oh, this is like kind of like a Python like markdown file here. So it kind of gives more, I guess, Pythonic centric like text, which does, I guess, improve the validation set at times as well.
No, that's a great point, and I think it kind of speaks to kind of as you were building out ACE, like what are some of the other types of challenges that you saw or were part of kind of the learning process as you were developing the paper and research finding?
Yeah, I can talk about that. So when we tried ACE for Apple, we particularly found that for coding a Apple is like a coding benchmark where there are different agents trying to perform a real world task. Sorry, can I start over?
Yeah, go for it.
Yeah, sorry. Yeah. So here, I think I'll just take a minute to like summarize what I want to say, and we can probably refine based on that. Is that okay?
Yeah, sure.
I would probably talk about I'll probably talk about like ACE being applied for a agentic task like Apple. And Apple, and I'll probably give a short intro about Apple, where it is a real world. It mimics a real world where the agent is tasked with some real world task, and it tries to interact with different apps and how to interact with and where to get information from and stuff like that. And we found that main challenges I'm gonna highlight uh, is uh, this this kind of thing um, requires a uh, lot of learning signals, because you kind of need to learn a lot about how to call different apps and what information to get from them and how to call different apps based on that. So this is a long horizon task which kind of requires a lot of learnings, and that kind of can lead to agent if the agent fails in one of them, then the agent then it will fail to perform the task. So it is very easy to not achieve the task because of a lot of fallbacks. So the some we kind of tried some experiments to get this signal where to get this signal of where the framework is where the agent is failing, and get the feedback more densely. So basically, we adapted to React framework. We tried full code, and then we adapted to React framework to get more to get the feedback signal more densely, and then that way we kind of help to we kind of had a playbook which kind of incorporates all the feedback. So basically, talking about how agentic thing could be really hard in real world, and then saying like what helped, how we kind of address that with React plus Ace to incorporate a lot of failures. Like Sangren cheating. Like, do we want to go with that question, or do we want to change this question to something else, like a little bit different? If that doesn't answer it,
I can summarize it if you don't mind.
yeah.
Okay. Yeah, if you want me to reprompt it, and then if you want to summarize it, I think that'd be easier.
Yeah, a big part of the challenge when we're trying to develop the framework is to test its validity in diverse benchmarks and applications. So just like we discussed at the beginning, the idea is very simple, which is to build an evolving prompt and to evolving context and to use it in these different environments. But one challenge is how do you evaluate the validity of these prompts or of your new context, and how to get new signals, how you incorporate these signals into your framework, especially for the agent application benchmark, the April benchmark we have. So one challenge is specifically how to make this framework feasible with the agent application with low overhead. So April is a benchmark featuring a large range of APIs, a lot of different tools you want to use. So you want to make sure that these information are properly captured, for example, by our generator and reflector, and properly kept in the context. And because this application is long horizon, it involves multi-turn and a very long context window, you want to make sure that the generated context has been properly used by the language model to improve its performance on the way. So this takes a lot of effort for us to get it to work smoothly and with low overhead.
Awesome. And moving beyond benchmarks, what are some of the real world applications that we're seeing and potential that you're most excited about to see ACE deployed, especially now that the code is open sourced?
Yeah, I actually have some anecdote to share on that front. So I have some like startup friends who are building agentic systems for workflow automation in CRM products for electronic enterprises. So the nature of these tasks is they're like highly specialized and customized, and it usually just use fully private domain data. So they try out the ACE idea in their context engineering process, and it turns out to give like massive improvements for the small Queen3 14B model that they're using for the agents. So for these type of like private domain and specialized tasks, usually the difficulty is for adapting any models to it is not that the model doesn't have like enough reasoning capability, or it doesn't have like general domain knowledge. For the agent to really perform well, what usually is needed is it needs to keep learning from the success and failure cases that it encounters during the adaptation phase. And having like a detailed playbook that with all the guidelines and strategies or the common mistakes for the specific tasks. So I think just to echo what we kind of talked about earlier, for such like private domain adaptation, any high level or general instruction is just not going to be enough. This is where the ACE idea can really shine, as it kind of provides like a framework for any task to just like develop a rich and self-evolving context for the agentic systems.
Yeah, and I think it's incredibly interesting, especially in the fact that it's using in this case you mentioned Qwen3 as a model. So being able to bring that using open source models closer to your own data, especially in an example like you just shared, is I think really great. I guess the other question would that follows from that is how scalable does this work? In the sense, like, do you need really big models? Can you work with smaller models? does long context really become an issue as a result of any of this? And in general, like, can ACE actually scale for production workloads?
Yeah, that's a very, very good question. I think so. As we have mentioned before, right? The kind of like ACE sort of like ride the waves of all of these, much more powerful long context models, right? But the long context as a kind of a playbook doesn't mean that ACE is kind of a very much time consuming or slow or kind of a compute costly framework. Mostly thanks to the go and refine system, right? So you every single time only just accumulatively adding a piece of these new bullet points into a playbook, and actually there's a lot of good system and infra set of improvement that can help you to accelerate the inference of the ACE, right? So that you can significantly lower your costs for these techniques like prompt caching, or for other things like parallel sampling, right? If there's a lot of ML infra set of progresses that actually making works like ACE can be actually be scaled very, very greatly. Yeah.
Yeah, also a lot of the techniques like what Chana mentioned, they would on a low level they would cache the intermediate representation, like KV cache of these long contexts, which can be stored and reused across different sessions and across different agents or different environments, which makes these the cost of these techniques even lower. And we think this is something that is happening a lot even after we have these approaches. And another thing is that when we build ACE, a very important philosophy is scalability and efficiency, because we've discussed a lot of the methods before that also work very well in this space. But the key challenges we discussed earlier are mostly in terms of how these methods are having troubles scaling to larger data sets, to longer horizons, or to scaling to more details in a context. So this is one specific thing we've been thinking about when we're building. There are quite a few examples that ACE can be used in a much more efficient way than we discussed in a production setup. One example is that because we're learning the difference between different contexts rather than the entire new context, which we call incremental delta update. So this makes update achievable in parallel by learning a lot of the delta contexts in parallel and then combining them eventually. Also, a lot of our frameworks are not dependent on language models. As an example, when we try to deduplicate entries in the context and make it much more dense uh, and, uh, and try to make it more compact, we use non-learning frameworks to make sure that these approaches are more tractable and low latency. So all these design points are baked into our philosophy of better scalability and efficiency.
And are there any other optimizations that you've been thinking about, or potentially integrations and optimizations with other frameworks like DSPY or JEPA?
Yeah, so something we touched the surface a little bit earlier is that we believe that ACE is not competing with a lot of the other work in the space. We think this is a very active research space, and many of these approaches can actually be used together with our framework. The one example we discuss a lot is JAPA, which I believe is definitely one of the best prompt evolution framework in the research space. One example JAPA can be used together with ACE is that, so for example, if you have a lot of the validation data offline and you have a lot of the compute, you can definitely run JAPA to get the best starting prompt you have. And then based on that starting prompt, we can gradually evolve that in the context of this, for example, like online agents, and make it even better with lower cost and better scalability.
Awesome. No, these are all super, super insightful. I think to wrap up, would love to also hear, we just announced that we've open sourced the code and are making that accessible to the community. Where else would you like to see ACE go as you continue to build on this project?
So one aspect we've been working on at this point is to extend ACE more than just an academic framework, but also something that people can use in production and in their own environments. So we believe that it's going to be valuable if people can use these directly from, for example, agent frameworks or from these programmable AI frameworks. So we've been working on integrating ACE with very mainstream frameworks like DSPy, and we're also thinking of maybe something like LangGraph. So we want the community to get started with ACE with the easiest way possible, and with the tools and frameworks they are already familiar with. And we also believe that ACE is more than just a framework, but also a new paradigm of doing things. How we imagine self-evolving LLMs with context adaptation. So we've been thinking about one thing is we want to further understand how the model is using the context, either in offline and online scenarios, to make these work even more valuable. And we're also looking at domain applications. Some of these that Fenglu mentioned also benefit a lot from ACE-like framework. So we want to extend it to more domains to see what are the benefits and what are some of the caveats we want to pay attention to.
Yeah, I think ACE has a lot of interesting applications, and there is a lot needs to be done that to understand the science of ACE and where it can be applied. So a few other things that we are thinking about is, so one interesting thing about ACE is it beyond the method, it also defines some certain principles of how to better design any kind of automatic prompt optimization tools. So we would love to see and take these sort of know-hows about avoiding brevity, avoiding context collapse, and go back and go to existing methods and see if we can improve them using these design philosophies. So that would be an interesting thing to look into. The other thing that we've been thinking about is the good thing about doing anything in the context space is that when you sort of fine tune a model and change the weight, it's very hard for the model to ignore or sort of handle out of domain distributions. When you change the context, the model can choose to follow the system prompt, or depending on the input, choose to ignore it also. So we do think there is a lot of advantage of ACE in out of domain kind of distribution shifts that people might see in an enterprise or existing workload. We have seen some examples of it in the examples that we have noticed around how ACE operates for a lot of these benchmarks, but we would love to go quantify all of these things and see if we can understand that science a bit more better.
Awesome. Thanks again for taking the time to talk with us on all of the fun stuff that you guys are working on. We're excited to see more, and I'm excited to see what people build with ACE now that it's fully open sourced. Any last words that anyone wants to share before we wrap up?
I said just go and try the code and comment, help us build ACE to broader impact.
I love it.
Yeah.
Awesome. Thanks, everyone.